Good morning, good afternoon, and good evening. I just want to go over a few housekeeping items before we begin. You should see a Q&A box directly on your screen where you can begin to submit your questions for today's presenters. Later today, you'll be sent a link to the on-demand recording as well as a link to download the slides. Without further ado, I will hand it over to today's presenters.
Thank you. Let me quickly share my screen here. All right, so yeah, I'd like to introduce myself. My name is Deva. I'm a principal product manager at Sev1. Joined about 2 years ago. I've been responsible in adding several different in the recent past and also some of the SD-WAN plugins that we've been working on. So in this session, I'm just going to be covering a hybrid cloud network observability story. We made a lot of progress in the last few releases to add new plugins, support new public clouds, so that network engineers can monitor, extend their visibility to the public clouds. About different kinds of deployment models that exist today, right? We see the most popular one being the hybrid cloud and also like multi-cloud deployment model. Applications today reside not just in a data center, in a private cloud. Organizations seem to be using a hybrid approach to basically see where parts of the application make the most sense. You know, when they need auto scaling ability, they host those parts of the application in the public cloud, or where it would make financial sense for them to host a part of the application on-prem, they host that pretty much on-prem. So what we see in reality for any application is a hybrid cloud deployment and also like a multi-cloud deployment. Like if you have orchestration platforms like Red Hat, you can build applications such that they just run across different public clouds. So these have become like really popular in the recent past. But what that has led to is kind of a lot of tool sprawl, right? For many network engineers, it's really hard when they're trying to troubleshoot an application issue. They have to jump between like several different tools to get to the bottom of an issue. I think I've been a network engineer, a cloud engineer in the past, and the amount of tools that we had to troubleshoot specific parts of the infrastructure really increased our mean time to resolution in the organizations that I worked at. Here's a survey from EMA. Like it shows on an average how many tools network engineers deal with while troubleshooting an issue, and you can see the reality is like 4 to 5 tools or 6 to 10 tools. It's really a lot. So we kind of like wanted to solve that while extending our visibility to the public cloud. I think Sev1 is known for monitoring really large-scale networks, on-prem networks, and we kind of wanted to give our users kind of a holistic view of their entire infrastructure so that it could reduce the mean time to resolution, break down the silos for data collection, and give them a really holistic view of what's happening on their application or the infrastructure. And the fact is, like, the public cloud is not perfect, right? Migrated from on-prem to public cloud. The promise was that it's always going to be up and running. There won't be any outages in the public cloud. But there's a 1,000-eye study on how many outages there have been in the recent past, and it's not really perfect. So with workloads split across on-prem and public cloud, you're really adding several different workflows and new variables to your troubleshooting workflow. So it's extremely complex today when there's an outage and you have to find out where exactly the issue is occurring, like across network engineering teams, across cloud ops teams. So it's essential to have a plan in place, right? You need to have a holistic view of your entire infrastructure and need a quick way to spot issues so that you can resolve issues quickly. And one of the biggest gaps in this EMA study that I posted here is public cloud visibility, right? Second only to like Kubernetes visibility. So we've been on a journey to basically tackle these top problems that network engineers face, and let's dive right into it. So in the 7 updates to our Azure plugin, so I'm just going to talk about the highlights of it. So we do support multiple subscriptions. If you have like multiple subscriptions that you need to monitor, you can just create like multiple different integrations. We're using a novel approach. It's called Data Plane API. That's something new that Azure has launched. You can group several different API calls that we do for data collection into a single API call. And that leads to a 50x improvement compared to many of our competition. And that what ultimately that leads to is cost reduction when you're doing the API calls. It's 50x more efficient when you're doing an API call for 50 different resources in just one call. And we partnered with Microsoft as well in the creation of this. So we went with a private preview approach where we tested the data plane API out, and when it went GA, we in 7.0 we call this solution as GA. So we added several different new metrics as well for monitoring, like express route circuits, express route direct, VPN gateways, storage load balancer, and yeah. So I think the list of resources that we support really help network engineers figure out whether there's an issue in their path to the VMs. So you would see things like load balancers, express routes, VPNs, which basically let anyone troubleshoot the connectivity to the VM, right? They already had visibility to several different network components, but we're just complementing that with network engineering focused resources for Azure. But we do have a roadmap of adding like several different other resources. And also one highlight that I'd like to point out is we simply have automated device adds. You don't really need to add these resources one by one to the NMS. Once you create an integration, it simply adds these resources to the NMS for monitoring automatically. You don't really need to add them manually at all.
And
so
Dava, just to
dive
just
right
a quick,
into it.
Yeah, just a quick question before we dive into the detail. You know, why would I choose Sev1 over the Azure built-in utilities? You know, what's our differentiator here?
I used Azure Monitor, they might know about the pain points of it. It's extremely hard to create reports. You have to jump between regions to actually find out what the issues are. And all of the cloud platforms make it really hard for you to find out like what exactly is going wrong in the network. It's kind of built as a reporting tool alone and not really something that finds out outliers. With Sev1, you have the ability to create alerts. You have the ability to do analytics, forecasts, and also look at multiple different regions at once, right? With the top end views, you're able to find out outliers and get to the issue right at hand. I'll give you an example of egress, right? Network egress. You can create a top end view to show you the network egress on each VM, and that will help you find the outlier of which VM is causing the most amount of egress that is like costing you money, right? Cloud providers don't really make it very easy for you to like spot that. So that's one of the reasons, but there are like many other reasons as well, like integrations, the ability to send data via data bus to a data lake if you want for further analysis, and also just data insight in general. Like it's a really robust reporting engine that looks way better than what these. All right.
Cool.
Let's move on to. Let's move on to some of the highlights of what we monitor. So in Azure, we started with VMs and VM scale sets. I think it's pretty straightforward. VMs pretty much run your applications. They're similar to the instances in AWS, whereas scale sets are pretty much your auto scaling VMs. And as you can see, I'm showing you an out of the box report that we ship with Data Insight. So when you install Data Insight, all of these reports they just exist. So once you create an Azure integration, you simply jump into Data Insight and consume these reports. So it takes you from integration to insights within minutes. So that's really cool. Like you just create an integration, find out all the issues in your environment, like higher CPU utilization, memory utilization, or like network in and network out data with the top end views. Next, let's jump into load balancers. So we support two different kinds of load balancers. There are global load balancers and local load balancers. Local load balancers pretty much split traffic between your VMs, and global cross-region load balancers split traffic across VNets. So it's really important to track performance metrics for this. Like I've been in organizations that have migrated from their on-prem F5 load balancers to like AWS load balancers or Azure load balancers. And network engineers at that point completely lacked visibility to what's happening there, right? And they were using native public cloud tools to monitor that. But it's important to have like both your on-prem and the public cloud in a single dashboard, so you can create like different workflows or alerts with and conditions and whatnot. So yeah, here there's out-of-the-box report for load balancers as well. So for each of the resource we support, we've created like out-of-the-box reports. So you can just jump into Data Insight and get started reports and modify them as necessary. Or you can decide to create like your own reports altogether with multiple different data sources. Azure Express Route was a heavily requested feature. So we support both Express Route Silk, the two offerings from Microsoft. The Express Route Direct offering basically gets rid of one hop for the service provider, gives you direct connectivity to Azure's infrastructure, whereas the Express Route Circuit like basically follows a service provider model. So we track all different kinds of metrics for network in, network out, light levels, several different metrics. Everything that's available via the Azure APIs for Express Routes, we monitor that. Virtual network gateways provide you connectivity in terms of like tunnels. So if you're creating a VPN tunnel from your on-prem to a VNet in Azure, you got to create an attachment for a VPN gateway. And also for the Express Route gateways, you have to associate them with a virtual network gateway. It's a big component in the path for packets to make it from your on-prem infrastructure to Azure when you're creating like tunnels. So we do ship like out of the box report for this one as well. And lastly, Azure Storage, right? Azure Storage is important to different kinds of storage that your application is using in the backend. So we support 4 different types: blob, queue, table, and file storage with all the different metrics that Azure exposes to us. So you can create like top-in views and drill down to outliers. A common theme that you would see is you never run out of clicks in Data Insight. In the device name, you can drill into a device summary. In the object name, you can drill into like the object summary and drill right into what indicators are outliers. And then you can drill into indicator summary and possibly do forecast analysis, calendar views, and whatnot. All right, let's talk about the Azure onboarding process. So it's a simple process. You don't have to create any infrastructure in Azure. Creating an app registration and a client secret. Once you create that, you get those values in the subscription that you'd like to monitor. You simply paste those values in the NMS UI. It's pretty much built into the device addition workflow. You go to the device manager, add a device, and you simply plug in those things that you just created, like the client secret, the app registration, the subscription ID. What that does is it kicks off the whole process in the NMS to actually reach out to the Azure APIs and add all the devices, add all the resources that you'd like to monitor. The next step is you simply jump into Data Insight and start consuming those reports and creating those reports. You can also like create alerts on any of the metrics that you're monitoring there. So we timed ourselves. It's simply a 2-minute workflow, gets you up and running really quick. Next, I'd like to talk about our AWS offering. So let's start with the limitations of CloudWatch, right? Like if you've used CloudWatch, you know it can be relatively long-term metrics. And also intuitive when you're trying to create several different reports in CloudWatch. CloudWatch is you switch between accounts, switch between regions to get to a bottom of what's happening in a report. So we try to like address all of that issue, kind of giving the user the ability to select accounts or even like show multiple different accounts and region in the same report. And actually, when you're trying to even look at the last month of data, last 2 months, last 6 months of data, CloudWatch can tend to be like extremely slow. Some of the options CloudWatch offers is storing that collected metrics in S3 buckets for long-term analysis, but that can end up in added costs. So we try to address all of those issues with limited data retention and just limited capability. And that's one of the reasons you would choose one to monitor your AWS cloud environment. So our approach to AWS monitoring is a little different from many of the other vendors out there. We use metric streams from CloudWatch that helps reduce cost incurred by doing recurring API calls to CloudWatch. The metric streams get written to the S3 buckets, and we simply make calls to the S3 bucket periodically to get overtime metrics, reduced cost compared to other solutions in the market that use CloudWatch API calls. We also enrich the metrics with a lot of metadata because it's easy to just collect metrics and have no context to what's happening, what's happening around it. Like you should be able to filter on, like say for example, a C5X large instance or M5 large instance, and be able to see metrics around it, to be able to filter on a metadata for a region and filter on multiple different regions and see what's going on in that region. So we do collect like string values and add them in as metadata. We complement the metrics that we collect also. And a common theme that you'd see across both the collectors is these are just built into the NMS. Once you upgrade to any version that supports these cloud providers, these are just simply built as plugins. You don't really need any external collectors, external hardware. You don't have to go through like sizing exercises or anything. It's simply built into the NMS. You simply need to upgrade the NMS and you get the functionality. So in summary, we monitor all of these components for AWS, and I can jump right into these. EC2 instances, pretty self-explanatory. We have out-of-the-box reports for these as well. So as you upgrade your data inside instance, or as you install a new instance that supports AWS monitoring, you'd simply see these reports right out of the box. So we cover important metrics like CPU, network in, network out, disk. We monitor S3 buckets as well, which is AWS's object storage offering, giving you neat top-in views of which storage accounts are taking up the most space, causing the most spike in your bill. We also monitor direct connects, which are basically the equivalent of the express route circuits. I would say direct connect came before express route. So we do monitor direct connect. We monitor things like light levels, network in, network out. When a direct connect goes down, you can have automation workflows that send webhooks to, like, say, for example, a Equinix facility to create a ticket to troubleshoot why exactly that direct connect is down. You can create several different workflows based on alerts that you can create based on metric data going down or up. Next, we monitor site-to-site VPNs. A lot of users use VPNs to connect different regions or even their on-prem infrastructure to the AWS. So it's critical to monitor those and the availability of those as well. And that is in a different state, it has one tunnel down, which is why it's showing orange, whereas another VPN is up and running. Next, we monitor transit gateways. Transit gateways can be considered to be a transport network in AWS. You have network engineers have been used to MPLS circuits or waves, wavelength, or EVPL circuits, right, for transport before. But this is transit gateway is used basically as a transport network within AWS. You simply create attachments to your VPC called TGW attachments, traffic up and running between different regions. It's very critical to monitor those, monitor packet loss across transit gateways between different regions, monitor drops across them as well. In the next release, we do have a roadmap of adding gateway attachments. So that is going to be an added plus. And lastly, Elastic Block Store, right? Each EC2 instance that you create, it is complemented with the EBS volume. There are times when the disk has some issues, EBS volumes have issues. You can't really catch that issue from a EC2 instance metric. So it's critical to monitor your EBS volumes as well. And we provide you out-of-the-box reports for those as well. Network load balancers are heavily used. As I mentioned, like there are many organizations that migrate their on-prem load balancers to the cloud, and they pretty much use network load balancers to load balance their traffic across different VPCs. So it's critical to monitor many different metrics for it, like for different protocols, TCP, UDP, TLS. So we provide you all those in the out-of-the-box reports, and you can feel free to like customize them, right? Us adding these public cloud providers into the NMS basically results in really neat workflows that you can create to troubleshoot multiple different infrastructures. Here, I'm showing you AWS cloud, and it's connected to a corporate data center via a site-to-site. It's basically using a 40-gate SD-WAN to connect to the AWS infrastructure via site-to-site VPN, and I'm showing you both the 40-gate metrics as well as the AWS metrics in a single report, and also the alerts for each on a single report. It's kind of CloudOps teams have been responsible for cloud infrastructure and they monitor their alerts, but when network engineers are troubleshooting what exactly is happening in an application, they're completely unaware of there could be something going on in the cloud. It belongs to the same infrastructure. So having the ability to see both in the same report is a game changer. And even more use cases, right? With SEV1, you have the ability to do capacity planning on each of the resources that you're monitoring. Many of the components, like you can pretty much auto scale your EC2 instances, but there are many that you need to plan for. For example, direct connects. They come in 1 Gbps or 10 gigs flavors. But what if you're running into capacity issues there? Or what if your forecast says that you will run into capacity issues in 3 months or 4 months? You need to plan for it. With SEV1's ability to be able to like forecast those, it can really aid you in planning ahead. Analyzing bottlenecks, as I showed you several different top ends. Make sure you focus on the real issues instead of just looking at graphs after graphs of irrelevant data. It always makes sense to kind of troubleshoot the outliers instead of looking at several different lines. And I used SEV1 previously to visualize our cloud migration status by just looking at how much traffic our transport links are doing and how much traffic is running on the direct connects. It gives you a neat view of how many workloads are running in the cloud and how much is running in the on-prem network. Really neat for executive reporting. And things in AWS are not really like always smooth. Like if you've run applications in the Southeast, AP Southeast region, you would see packet loss from time to time. So it's really important to track those packet loss and kind of like track the SLA that AWS provides for different services from a vendor agnostic tool. So you can go to AWS and say, hey, like we didn't really meet our SLA for this month. And I'd also like to talk about the application dependency mapping, right? Since we collect so much information in metadata, you can simply filter on a VPC and you can see all the resources that are associated with that VPC. And that's the power of metadata in Data Insight. You can simply create filters based on those metadata, create a filter on a VPC, and you can see the NAT gateways associated with the instances that are associated with the TGWs that are associated with it. In summary, we offer all of these resources today as of 7.0 release, but we have a roadmap of adding even more. So if you have resources that are important to you that you don't see in this list, do create an idea in AHA, and we should be able to like add that to our roadmap after doing an analysis. So we've been on this journey, right, from 6.5, where like we monitored all of these network components on-prem. We have a neat workflow of doing device certification. Within 10 days, you get a device cert and you can get up and running, monitoring your SNMP, monitoring these devices by SNMP. In 6, the visibility to AWS, adding in like 5 different resources from AWS. In the 6.7 release, we did an Azure private preview with virtual machines and virtual machine scale sets. It's kind of like expanding in scope the things that we monitor. And in 7.0, we can claim to be a truly hybrid cloud monitoring platform. that monitors both Azure and AWS, in addition to the on-prem infrastructure that we already monitored. So let me jump right into a demo. All right. So in this report, I've basically connected to two different data sources. One is a Fortinet one and one is a AWS one. And I'm showing you both infrastructure in a single report. Like in here, I can see I have 5 nodes in my US East 1 region. The Fortinet SD-WAN footprint report shows you that the Brussels and Venice side are connected via VPNs as well. So it's really neat. Like I'm actually monitoring Azure and AWS in a single NMS, and then I'm monitoring Fortinet SD-WAN in a different NMS altogether. That is, you can connect to multiple different data sources and visualize it in a single report. You can also have alerts from all these different reports. So here I can see I have some Azure alerts, AWS alerts, and my Fortinet SD-WAN environment is up and running as expected. With Azure stats here, AWS stats here, and also like SD-WAN connectivity, right? You can monitor whatever you'd like and create tabs for each that can really aid you in your troubleshooting workflows. I think that covers my demo. I'd open it up for any questions.
That looked really good, Dave. Just thinking about the future, we talk about at the opening, you talked about covering the top 3 vendors. So far in the presentation, you've covered AWS and Azure. What about GCP?
Yeah, so GCP is something that we're working on today. So we're looking for customers which we could partner with to understand the requirements, but we do have a roadmap of supporting GCP in the 7.2 release. And it's going to be extremely similar to what we support today in AWS and Azure. We're going to be targeting a lot of network engineering focused metrics.
Cool, thank you.
I'd also like to point that we do have a rich roadmap of enhancing these, right? In this release, we are trying to focus on collecting tags. We are aware that tags are important to a lot of users. So being able to collect tags as metadata, limit resource collection by tags, and also VPC flow logs in the future, right? We are trying to explore all the different options to add more features to the existing plugins and also support new public cloud vendors. All right, any other questions from the bridge? All right, I think I can hand it over to Susie. Susie, if you're speaking, you're muted.